Hi, good morning, everyone. My name is Pushkar Nandkar. I work at SambaNova Systems, and today I will talk about SN40L. That's the chip that we've built, and I know how it enables the Agentic AI. So I'll not go into this slide. Jay already talked about it, and multiple others have already talked about the journey towards this Agentic AI systems. Briefly on this, now we have multi-agent systems, which are basically each agent is having its own context. There are multiple LLM calls that are made by these agents, and they also use tools. Now with this, the user experience have changed a bit because the tokens that are needed for serving such applications have exploded a lot. So the inference providers need to provide these tokens at a very high speed. So we have built a full stack solution for serving agentic AI from RDUs to products like Samba Cloud, Samba Stack, and Samba Managed. We can talk about these products later. Today we'll focus on SN40L, which is the chip that enables all of these products for us. So diving deeper, each of the products that we have has a rack backing it. And each rack has around 16 RDUs. And these RDUs are basically the the inference serving engine that we have. Each RDU has compute, which is in the form of tiles, and the backing memory is HBM and DDR. So the tiles themselves have what we call as PCUs and PMUs. PCUs are pattern memory unit, pattern compute units, and PMUs are pattern memory units. So these units are formed in a mesh, and they form the basis of Dataflow, which we'll touch later. The three-tier memory, the SRAMs that are part of the PMUs, the HBM and DDR form the memory system that will hold multiple models together. Now, what is Dataflow? So if you see, this blue box is basically the attention mechanism that's there in multiple LLMs. And these attention mechanism can be further divided into multiple operators or kernels. In traditional GPU systems on the left, you have these operators getting inputs from the memory, and then they save the output or the result into the memory once the execution is done. So this forms a stop and go kind of execution, many times bottlenecked by memory bandwidth. Whereas on the right side, you have the RDU, which is basically data flow architectures where these blue boxes are PCUs and PMUs. These operators are mapped onto these PCUs and PMUs, and the input streams, which are this QKV, for example, are just, they form the input stream, and you just let the data flow so that the output result is present back onto the memory. So this spatial execution actually helps to provide a lot of compute density and compute efficiency. For example, Llama 3.18b can be is shown here with multiple layers. For each decoder layer, the K1, K2, K3 are actually the GPU kernels that will get executed with a stop and go mechanism. Whereas for SambaNova, SN40L, you have just one K0 kernel which will execute in one shot. And these decoders can be further fused into something called as loop decoder with kernel looping. So you have a 3.18b model now just running 4 different executions. So this kind of helped us go from baseline 100 tokens per second. With single decoder, we got to 500 tokens per second, and with temporal fusion or kernel looping, we got to around 1100 token per second for 3.18b. And along with that, there is power efficiency. We can run multiple models on single rack machines, whereas others will take multiple racks to run such models. And for agentic AI, you have multiple applications with multiple models. What happens is traditional GPU systems with these multiple models need to be served by separate set of GPUs. Whereas for SambaNova, because we have DDR, we can actually serve these models on a single rack where all the models, the DDR is almost like 24 terabytes. So you can have as many models as you want, as many weights as you want, as many fine-tuned checkpoints as you want, and serve from the same system. with very low switching latency across the models. So this again shows the same thing. You have one endpoint which is serving all the inference requests, and multiple fine-tune experts can be served on this system. So this helps with memory efficiency, power efficiency, compute efficiency, and you have much better control, and you can enable complex workflows within a isolated environment in your data centers. So for different models, this is the artificial analysis data. We have all the speeds are mentioned here, and these are the models that we are serving. So multiple models from Meta, Qwen, DeepSeek, OpenAI. So yeah, I had very little time, so I had to rush through all of that. But feel free to catch me. I'm here throughout the day, and you can read about it, try it. There are multiple papers out there about the architecture, and feel free to talk to me. Thank you so much.
Okay, thank you.